In this video, we're going to determine the molar mass of an unknown compound. In this particular problem, it's hemoglobin, which is a very large protein found in the body, and specifically in the blood. So we're going to use a colligative property called osmosis to figure this out. You can see the example right here, but before we get started, let's know what the goal is in our problem. Really, our goal is to figure out how we can determine the amount of moles for our unknown, in this case hemoglobin. And this is going to be found by using the colligative property to determine concentration. This works not only for osmotic pressure, but it can work for any colligative property, or really any type of problem, as long as you can find the concentration of the solution. So recall, if the concentration that you find out is molality, then from the problem, then we need to just multiply by the kilograms of the solvent. If in your problem you're finding the molarity, which is determined by the equation that you're using, then multiply by the volume in liters of the total solution. And a couple of examples are given here so you can numerically see how that might work out. Now, remember, our goal is to find the concentration, which is molality for the freezing point and boiling point problems, molarity for osmotic pressure, and mole fraction if you're doing Raoult's law, because the concentration is the key. Now, if we dissolve 35 grams of hemoglobin in enough water to make a liter of solution, you can measure the osmotic pressure, and it was measured to be 10 millimeters of mercury at 25 degrees. Let's calculate the molar mass hemoglobin, but remember, our goal is to get to concentration. And before we get to that, we've got to use the pressure in millimeters of mercury. That won't work, so it's got to convert to atmospheres, which can be done by dividing by 760 millimeters of mercury for 1 atmosphere. That's equal to 0.0132. And using the osmotic pressure equation, we can determine that the unknown that we're looking for here is molarity, M, capital M here in this particular one. The pressure, the pi symbol is given. R is the gas constant, T is temperature, which is given. I is the Van Hoff factor. So, but remember, we're going to try to solve for molarity. And we can do this, especially if we assume the Van Hoff factor to be 1, which is a good assumption since hemoglobin is not an ionic compound. So, rearranging the equation to solve for concentration, or capital M, we can see here by plugging in the gas constant of 0.0821 liter atmosphere per Kelvin mole, and 298 once we convert 25 degrees into Kelvin. We can solve for the molarity, and it's 5.39 times 10 minus 4 moles per liter. The units all cancel out, atmospheres cancel out, Kelvin cancel out, and you're left with moles per liter. Now there's our concentration, and if we multiply it by the volume of solution, which is 1 liter, given in the problem, we can find the amount of moles that we have for our unknown sample. Now to calculate the molar mass, since we know how many grams we have, given in the problem, 35.0 grams, we can divide that by the number of moles just calculated, and we come up with 64,900 grams per mole. That's a very large number, and it seems astounding, but this is a typical molar mass for a large protein. And now we have some steps into figuring out how to calculate molar mass of unknown compounds.